Right, well this is the CB I wanted to do yesterday, but Mark wanted me to do the PNI. This is the DNT Ralleye CPT only set. And it's come with the box, but the box is empty of anything other than the radio. I had to collect this 257 miles away in Wales. The person wouldn't post it. So I drove 257 miles, stayed in a hotel, drove back 257 miles. There was some other church business from which there was no fruition, so it was a very expensive CB. Now I've looked on the internet and I've managed to download a square kit diagram. So that's better than nothing. So that's how I'll have a look at this box. Has an external S-meter socket, and it does come with the original motor. Do you know what? I think I had to pay 30 quid for it as well, but it's in nice condition, but pretty useless. I'm going to pause the video and see if my Datsun screwdriver fits. Right. Now armed with the Datsun screwdriver. These are a bit small really for this, but it hasn't. It doesn't feel like it's going to damage the. You've probably seen these double-ended Datsun screwdrivers. I managed to get this off eBay for £1. This arm, I didn't put the soldering iron on, which I should have done, because the chances are I'm going to have to unsolder the speaker. I nearly said squeaker, which I normally would. Yes. That's interesting. Why would the control IC be in a socket? Since you never put these in a socket. Oh, well, that's really weird. Okay, well it looks to be the right one, except it says on the circuit diagram 5121-01, and this says 512109. Hope this hasn't been turned into something else. After my 500 and something mile round trip. Right, we'll power it up. Unsolder the speaker. Plug in the test equipment. Plug in the test equipment with the speaker connection. When I find which one it is. Extension speaker. Oh, the other socket is external S-meter, and it's a 3.5mm jack, which is, I think they're only 2.5mm those. Right, moment of truth. I'm going to find out what frequency it's on. So normally we look at the power level, but we're going to look at the frequency. I'm going to pop this onto channel 20, so it should be 27205 because it's CPT. Oh, you've got to unplug the speaker, have you, because it plays silly what's it. It is 27205. I've only just put the test set on 5 minutes ago, so I'm not going to adjust the frequency. If it is adjustable, I'm not going to adjust that for I'll start again until the test set's been on for half an hour. I got 20 minutes before lunchtime. I thought, do I go in the chapel and get on with the organ, or do I start a CB? I thought I'll start a CB. I'll probably get further through it than setting myself up painting more mind-bogglingly boring rollers. So someone's fiddled with the VCO. So I'm just going to check it locks on channel 40. It's an LCD display, which at this time would have been pretty state of the art. So I'm going to go into 3-watt range on the test set, so it should bang across, which it does. I'll go to channel 1. They wrap around, so you can go from 40 to 1, and again it bangs across. So I'm happy that the VCO is going to be set about right. If I needed to adjust that, I'd have to start looking up things we have got a manual for. It's probably about 1987, this, that would be my guesstimate. Oh yeah, there is a crystal trimmer. There's a red capacitor actually between the two legs of the crystal. So without even looking at the circuit diagram, we've clearly got this as our transmit lineup. And without further ado, you know what, we'll tune it up. So we've actually got 4.05 watts. Oh, power supply needs dropping. How do we do that? There we go. There we are. Spot on the 4. Now it's at the right voltage. Spot on the 4. So very good. What does it use? 2SC2078 for the output transistor. It's nice when I can see that. I'll take a photo of it and we'll do a black and white printout, and then I can write down what the different adjustments are. So there's 3 FETs there. Got crystal, 2-pole crystal filter. So really should be quite some selectivity on this. Right, I'll go and get a camera, we'll get a photo taken, and we'll take it from there. Right, I've been busy. So, we know these are transmit. We've got deviation there, VR6. The set's been on long enough to adjust the frequency, so we'll do that right now. So we've got 27, oh, of course, it's come on a different channel. There we go, 27205 we should have. So it's still low, 27204.88. Just adjust that trimmer. Over the top, see if I can just drop it a fraction. Ho ho! Ha ha! Can't be bad. Right, deviation. Wallow. 1, 2, 1, 2, wallow. 2.5 a spot. Wallow. It's actually exactly where it should be. 1, 2, wallow. Probably could do with coming down a fraction. About 2.6 peak. So that's deviation. VR6. Trying to find where the microphone is. Let's try to that. Testing 1, 2, wallow. That'll do. Right, we'll go over to receive. Plug the extension and speaker back in. Very noisy volume control. So just see what the cyanide reading before we start is. $27,205, yeah. 0.44 microvolts. Let's make a note of that. See if we can get any more out of it. That looks pretty decent. So we'll start with the detector. Put an S9 signal, 100 microvolts. The oscilloscope on there. Detector is this. That was slightly out, but it's a bit finicky. Out of interest, see what the S meter says. Out of interest, we'll see what it says on transmit. Full set. I'll come back to that when we've disconnected the external speaker again. So out of the 5 bars, what should be S9? Well, detector appears to be, the S meter appears to be VR5, which is there. And that certainly affects it. I have it just onto that. But also, it's possible that VR4 can affect it. So we've got VR5. So VR4 is kind of the overall one. So if you've got an external S meter connected, which we haven't, we could set that so that reads S9, and then you trim this one to make sure this also reads S9. I just don't think I've got one. Look, we do have one. They're not cheap, are they? I think I paid about 40 quid for mine, and it's only a meter in a box. So that's what that's about. So VR4, that one, It's kind of the overall one with reference to external S meter, and then VR5 is the actual S meter on the set. So that's those two. So we've got a squelch preset. That is either power on transmit, or it's a takeoff for the RF meter if it does that. So I'm just going to go back to transmit. Turn that down. Oh no, yeah, we'll have to go back to transmit. Unplug the speaker. So I'm going to keep an eye on the meter. In fact, we'll both keep an eye on the meter. So when I key up, does this affect transmit? It does. So it is transmit power, and it's doing 4.2. So we'll just drop that to 4.1. Out of interest, let's see if I drop the power, whether the bar graph drops. No, it doesn't. So it's an early pre-programmed one that just gives you 5 bars, whether it's doing 1 watt or 4 watts. That's interesting, isn't it? Because this is, I thought that predates all this pre-programmed rubbish. So we can now say that VR7 is transmit and it's power. I mean, it looked like power from the circuit, but I just couldn't be sure. So go through the receiver, plug the extension speaker back in. Switch the cyanide meter on. Making sure the squelch is down. So we've got about 4 dB on that. Just put the soldering iron on because clearly they all need to be done like that. I want to go for transformer 1 first, but not all of them are labelled. But 2, 3, 4, 5 are labelled. So 2, 3, 4 and 5, 1. So if we've got 2, 3, 4, 6. 2, 3, 4, 5 for the detector, 6. So surely that must be 1. I'm going to say T1 with a question mark. Because it's got wax here, we can't see what it says. So I'll start there with T1. T2. T3. T4. Just put a bigger signal on, that looks like it's IF. No, I can't see it on there either. Let's go back to a low signal. Can't see whatever I do. See if we can see it at 20 dB. See if we can see it at 12. see it right down there. See, we can see it with a whacking great big signal on this telescope. No, I can't see that at all. I would think it's balancing the filter. Let's see if I can see it on the circuit. T6. Yeah, well, what can I say? Right, we'll go over to T4. And that we can see. No. Anyway, we'll have a now look to see what we've got for our receive sensitivity. So for 12 dB, which is actually about where we've got it, it's still 0.44. It hasn't changed at all. So for 10 dB, it's 0.37. For 20 dB, it's about 1 microvolt. It's got a different scale. 1.15 microvolts. So I'll just make a note. It was 0.44 microvolts for 12 dB cyanide. Now, that brings us on to the squelch. So I'm going to put the squelch to full on the radio. We'll advance the signal generator attenuator to 3 microvolts, 10 microvolts, 30 microvolts. I want it to come in at 100. It doesn't. 300, 1 millivolt. No, it never ever comes in. What a wonderful squelch. One that never ever comes in. So VR3 we will adjust. You know what? The volume was down. Let's try that again. It doesn't seem to have any effect. Let's look at the circuit. VR3 is in line with the squelch control, so it has no logic. I just can't tell which is the right end for this. I just can't see any difference. So I've got that really on the verge. No. We'll go to the other end. See where the sensitivity is at this end. Set the threshold. Switch the signal generator on. I'm going to have to clean these controls, I think. Alright, try again. Switch on. Oh, coming in about 1.3 microvolts. Leaving at 1. Not good. Right, that's proved that's the more sensitive end. We'll do that test again. Threshold. .2 it's coming in at, leaving it 0.7. So that seems to be where it is. And maximum squelch, oops, that's maximum volume. Maximum squelch is now 100 microvolts, just where we want it. So spraying that control has brought back the preset operation. So that's where we are. That's good. So that concludes it. We'll put it on the aerial. Good. So switch it off and we'll just make sure we've got the positive and negative right for the speaker. Not that it matters. I'm just being exact. So if the black's negative, let's see if it really is. Well, that certainly reads to chassis, and that doesn't read to chassis. I see Lidl have got a multimeter for £9.99. I must get one of those. Right, put the aerial on it. Unplug the extension speaker. It's nice to have the original mic with it, with it being a funny shape. So it has a channel 9 switch. How thrilling. Up down on the radio and on the mic. So we'll start off on 19. One nine, Roger. Somebody said 27's calling channel, but I've not seen that anywhere. That sounds like AM or SSB. 27 for a Roger. Sounds like data. Right, well, to be expected, not hearing anybody on there apart from a bit of foreign interference. We're doing on the air test with this with Mr. Chippy, and we'll see how it works out. So thanks for watching the DNT Ralleye CB radio from about 1989.